This is the last section in our packet before we're going to be moving on to the next packet and next chapter. I have to talk to Mr. Harmon and see if we're going to be doing a chapter test or if we're going to just be moving right on. With so much lost time with October being crazy with the back-to-school schedule and the extended homerooms and missing periods, we might just move on. We'll see. I'll let you know. But today we're learning the last section, rewriting equations and formulas. So basically what we're going to be doing today is seeing equations like 3y plus 4x equals 9. And we're going to take this equation and we're going to solve it for a specific variable. So this equation, 3y, and if you don't have your packets, just write what I'm writing on the board on your piece of paper. 3y plus 4x equals 9. We're solving this thing for y. So similar to if we were just solving a regular equation with just one variable and then everything else numbers, we're still going to follow the same exact steps. We're just going to have other variables in our answer, and we won't just get like a final answer like y equals 2. We're going to have a weird answer. So we're going to basically take the same steps when solving an equation, which is the opposite of the order of operations. So we're basically going to undo addition and subtraction first, and then undo multiplication or division. So this is what we're solving for, this y right here. To solve for this, we have to get rid of this thing right here, this 4x. So to move that to the other side, I don't want this to look like division, so I'm going to erase this. To move this to the other side, we do the opposite, the inverse operation of addition. So to move this over here, we're going to subtract both sides by 4x. When we do that, on the left-hand side, we'll just have 3y left there. And then on the right-hand side, don't get confused. You can't do 9 minus 4x and say that that's 5x. It's just going to be 9 minus 4x. So we just write it like that. You good?
Yeah.
Writing this down? He's not his head. He's in agreement with me, but he's not writing it down.
I don't need to write it down.
Oh, he doesn't need to write it down. I gotcha. All right. Well, then the last thing we would do then, Chase, is what?
You would, I think that's the answer.
It is not the answer. We're solving for y, and we need to get rid of the 3. What's happening with the 3 right now, Chase?
Oh, yeah, you divided by 3.
Yes. We'll divide the whole thing by 3. Good job. So when we divide by 3, these 3's go away, and we're left with y equals. Now, this looks kind of crazy. 9 minus 4x all divided by 3. This is technically the answer. This can be simplified, though. So this is the answer. I'll be very happy if you get to this part. But then you have to think to yourself, can I simplify this a little bit to make it easier? And we can. I can divide 9 by 3, and I can divide this by 3. This will just end up being a fraction. But if I go to simplify this a little bit better, 9 divided by 3 is what? 3. So I can just simplify this down to 3. And then this is going to be minus 4x over 3. There's nothing I can really do with that because that's just going to end up being a fraction. So we can simplify it like that as well. Basically just splitting up the fraction, instead of it being one whole fraction, splitting up into 2 separate ones. Both of these are correct answers. If it says simplify, like to the furthest it can be simplified, the second answer would be right. If I said solve for y, either one would be right. So it really depends on the way that I ask the question. So the next one is y equals 4x minus 2z. And this one we're now solving for x. So I think it's really helpful at this point to circle the variables we're solving for so we know exactly what our whole goal is. In this problem, we're solving this thing for x. So looking at the equation, x is on the right-hand side of the equal sign. And next to the x, directly next to it, in front of it, I have a 4, but I'm not going to deal with that yet. What I'm going to deal with first is what's behind it, the minus 2x. How can I take that minus 2x and move it to the other side? What would I do?
Add to both sides.
Yes, we're going to add it to both sides. So instead of minusing 2x, to move it to the other side, we're going to add, oh sorry, I said 2x, but I meant 2z. We're going to add 2z. to both sides. Don't get confused when you're adding things that are not like terms. Y plus 2z, I don't know what that answer is. It would just be y plus 2z equals, and then 4x on the right-hand side. We're solving this thing for x, and it's going to be a weird answer. It's not going to be a nice, easy number. We're going to have variables and all sorts of things going on. What's the last thing I would do to solve this? To get rid of that 4 in front of the x. Yes? Divide by? Yes. All right, when I divide everything by 4, I'm going to get this weird answer as my answer. Y plus 2z over 4, and it's right. The answer is x equals y plus 2z over 4. So this is the answer. If it says simplify as much as possible, we can do what we did with the first problem and basically separate it into two separate little parts, two separate terms rather than one whole fraction. So another way to do this would be x equals. You would take the first part, y divided by 4 like that, and put that as one term, so that would be y over 4. Plus, you would then take the second term, 2z over 4. Like this. But 2z over 4 can be simplified because 2/4 can be simplified to be 1 over 2. So you could basically simplify 2/4 z by dividing 2 out from each one. 2 divided by 2 is 1, 4 divided by 2 is 2. So this will end up being just 1z over 2 as the simplified answer. So that says x equals y over 4 plus z over 2. If you're comfortable with the first equation answer, that's fine as long as it doesn't say simplify to its most possible, what am I trying to say? Simplify completely, I guess. All right, so is there 2 practice problems under there? You try. Mm-hmm. All right, what I want you guys to do here in front of me and everyone at home, try the next 2 problems. I'll give you guys a couple minutes. Obviously, everyone that's here, you guys can talk to each other. You can work these together. For those of you at home, you can try them on your own, and then in a couple minutes, we'll go over them together. Oh. Really? Is it a really good? I like it. That's cool. Is it freshman? Saturday?
So not the Saturday.
And our Fanta?
When you add extra
Yeah. So we're solving this one for y. So you want to move the x. So you're going to want to do the opposite of minus x and you're going to add x.
Yeah, I think.
Okay. Does that work for you guys?
No,
everybody at home, if you guys have any questions, just go ahead and either just start talking or send a message. In like 1 or 2 more minutes, we're going to go over the answers. You girls doing? Doing okay? Yeah.
Solving for y. Yeah, y equals 2 really Yeah. You don't believe x is in the problem. No, it's not. You took it out, buddy.
Alright, let's go over these answers. And instead of just going over the answers, I'm going to go through the whole step so you can see how to solve the problem. So for both of these equations, we're solving them for y. I think it's helpful to circle the variable you're solving for so you can kind of see what's going on and what you need to eliminate, what you need to cancel out. So whenever you're solving an equation and you're solving for a particular variable, you're going to want to get rid of the addition or subtraction that's next to it. This is the minus x. To cancel out a minus x, we will do the opposite, which is adding x to both sides. When you do that, you're left with 3 times y equals. Be very careful. When we're adding 7 and x together, we don't know what x is, so we wouldn't just say it's 7x. It will literally just be 7 plus x. You can't do anything with it because we don't know what x is, so it's just going to be 7 plus x. The last thing you would do is get rid of the 3 times y by doing the opposite of multiplication, which is division. So I'm going to divide everything by 3. This by 3 and this all by 3. And the answer is y equals 7 plus x over 3. This cannot be simplified. That's just the random weird answer for that problem. The answer is y equals 7 plus x over 3. All right, and then the next one, 20 equals 5x plus 4y. I'm going to just rewrite it. We're solving for y again. I'm going to circle my variable to kind of see what I need to eliminate. First thing I need to do is get rid of anything that's on that, like a different term that's not attached to the y. Can't get rid of the 4 yet. I'm going to get rid of this 5x by doing the opposite. This is a positive 5x that's being added. I'm going to subtract it from both sides. When you subtract 5x from 20, you will not get 15x because they're not like terms. When 20 minus 5x is literally just 20 minus 5x. So this is what your next step would be. 20 minus 5x equals 4y. And then what would the last thing we would need to do? Divide. Yes, we're going to divide by the number in front of y, which is 4. And my answer will be 20 minus 5x all over 4 is equal to y. Now, if you wanted to try and simplify this further, you can, because 20 divided by 4 is 5. And you could just write 5 minus 5x over 4, but we'll just leave it at this. This is totally fine to leave it like that. All right, the next example is definitely more tricky, because if we're looking at this, we have x equals 3y plus 2yz, and we're solving this thing for y. I have a y here, and I have a y here. This one is hard because if you want to solve this thing, you would probably want to add 3y to 2yz, and it's not going to work because one term just has a 3y and the other term has what else with it? A z. And I can't add something together that's not a like term. So I can't add 3y plus 2yz and say I have like 5 of something because I don't. 3y's literally looks like this. 1, 2, 3. That's 3y's. 2yz's looks like this. yz, yz. You can't add these all together and say you have 5 of the same thing because they're different. So when we go to solve this type of problem, we can't just add them together and then solve for the variable we're looking to solve, which is y. What we have to do is something called factor. We have to take this y and factor it out of both of the terms. It's basically the opposite of the distributive property. So what we're going to do is take the y out of both of these terms, 3y and 2yz. If I take a y out and I put parentheses in, it basically is going to look like the distributive property before you would usually distribute. If you take 3y and you take the y out of it, what would you still have to have in the parentheses so that it still would equal 3y? You take the y out, well, what would you still have to have there? So if I take this y out of this term right here, what would I have to put here so it still was equal to 3y? Yes, we would need a 3 right here. If we factor out a y, we will still need a 3 for it to still equal 3y. Plus, if I take a y out of this term has 3 things. What would I still need on the inside of the parentheses so it still equals 2yz? If I take the y out, what will I need, Maya? 2. Yes, I'll still need 2 and a z, exactly. So I would need 2z here. Basically what we did was the opposite of the distributive property. The distributive property says multiply the number on the outside by everything on the inside. Factoring says take that number that is in each term and pull it on the outside. Now, we have only one y. Before, we had 2 y's, which was hard for us to work with because we didn't have like terms we could combine together. Now, we have to realize that this right here, y, and all of this is being what? What operation is happening between the y and the stuff in the parentheses? Yeah, it's distributive property, which is what operation? Multiplication. To cancel out multiplication, we divide. So we're going to divide by all of this stuff right here. 3 plus 2z. So we're going to divide, oops, I keep writing 2x. This should be a 2z. So we're going to divide everything by 3 plus 2z. When I divide by 3 plus 2z, those cancel right there. And then this answer right here is going to be our final answer, which is weird. The answer is y equals x over 3 plus 2z. And the way that we got that is by first factoring out the y, since we couldn't combine them together. And then once we had it factored, all we needed to do was divide. So the whole point of this section is to show that it's helpful for us to solve for different variables with common formulas. So what we're going to do now is look at some common formulas we use all of the time, and we're going to solve for specific variables. For example, the formula A equals L times W is the formula for what? A equals L times W. What's this formula for finding? Maya? Yeah, this is the area formula for a rectangle. So what we're going to be doing is taking this formula and solving it for W. If I said you have the area of this rectangle and it's this, and you have the length, what's W? You can take this formula and you can solve it for W, and you can find an easy, quick way to get that answer. What would I do to solve this for W? There's only one thing I have to do. Chase?
Divide the area by the length.
Yeah, so we'll have to just divide the area by the length, and we're going to get area divided by length is equal to width. Exactly. formula for? It says P equals 2L plus 2W. What does that formula stand for?
Perimeter.
Yes, this is the perimeter formula for a rectangle, which is take 2 and multiply it by the length. So take the length, multiply it by 2 since there's 2 lengths. Take the width, multiply it by 2, and then add them together, and that would be your perimeter. We're going to take this and we're going to solve this thing for L. I'm going to rewrite it because I'm short. 2L plus 2W. We're solving this for L. I know this kind of looks like a 1, but it's an L. All right, so to solve this for L, what's the first thing we would want to move to the other side to get it to be out of the way? What's the first thing we would want to move to get it out of the way? Well, let's look on the same side of the variable we're solving for. We're solving for this right here. We can't get rid of the 2 just yet because it's attached to the L. So what would we have to get rid of first?
You divide 2W.
We will eventually divide, but when we're solving equations, I think it's easier to do the opposite of PEMDAS, which means start down at the bottom, work your way up, get rid of any addition or subtraction first. What's being added that I should just move first? The 2L is what we're solving for. Try again. Yes. Let's move the 2W. Right now it's being added, so to do the opposite of that, we would subtract 2W from both sides. Okay, is everyone with me so far? Basically, I moved this term because this term was just in the way. Now we have P minus 2W equals 2 times L. We're solving this thing for L. Now the last thing we're going to do, which Eli said, is aren't we going to divide? Yes, we're going to divide by 2. But it's easier to divide once you have everything away from it and there's only one term left. So the answer would be that the length is equal to the perimeter minus 2 times the width divided by 2. That would be the answer there for that one. So now that we did the notes, now it's time for you guys to try these problems on your own. There's 6 problems on the back that I would like you guys to work on, and then before we leave class today, we'll go over the answers.